So we started Unit 10 today in class, and Unit 10 is dealing with counting methods and probability. And what we started with was ways that we can come up with the number of ways to perform a task, or the number of ways that something can happen. One of those ways, if you actually want to see the combinations that you have, is to use a tree diagram. For example, it says the sporting goods store offers 3 types of snowboards and 2 types of boots. How many choices does the store offer for snowboarding equipment? Well, each part of the problem is going to be its own level of branches. So for the first level, we would have 3 branches that would represent the types of snowboards. We have the all mountain, the freestyle, and the carving. And then from each type of boots, or each type of board, you then have 2 types of boots you can choose from, the soft or the hybrid. And then you can see, if you follow the branches, that you have 6 different choices. Now this was a pretty small problem, and so a tree diagram would work just fine, but sometimes it's not practical. Like we were talking about like Applebee's menu, and you were trying to figure out all the different choices that you would have to order. A tree diagram would just be impractical. It would be way too big, and it wouldn't give us the information. And so sometimes when we don't actually need to see our choices, we can just come up with a number of choices using the fundamental counting principle. And this is where you take the number of choices at each level and you multiply. For example, for this problem, since I had 3 boards and 2 types of boots, I would do 3 times 2 and I could come up with the 6. If you look down here at this example, this is just another example. It says at a blood drive, blood can be labeled one of 4 types, one of 2 RH factors, and one of 2 genders. How many different ways can blood be labeled? Well, there are 4 types of blood, 2 RH factors, and 2 genders, which gives you a total of 16 possible ways that blood can be labeled. The second example says, as a used book sale, you are interested in 5 novels, 3 nonfiction books, and 7 comic books. If you buy one of each kind, how many different choices do you have? Well, you have 5 choices for the novels, you have 3 choices for nonfiction, and 7 choices for comic books, which gives you 105 possible choices when buying one of each kind. Now, when you're looking at the counting principle, sometimes you also have to determine if there's any rules or restrictions being placed on them. For example, this problem at the top says, the standard configuration for a Texas license plate is 1 letter, followed by 2 digits, followed by 3 letters. And for part A, it's asking how many different license plates are possible if letters and digits can be repeated. Well, think about the spaces that you have. You are filling in 6 spaces on the license plate. And just going step by step, figure out what you have, what number of choices you have for each blank. Well, the first one is a letter. We have 26 letters in the alphabet, so we have 26 choices. The next one is a digit, and by digits they're talking about 0 through 9, which is actually 10 digits. Now the next blank is also a digit, and so since you can repeat digits, this would also be 10. This would be 26, this would be 26, and this would be 26. And when you multiply those together, you get 45,697,600 different license plates that you could come up with. If you look at example B, it says how many different license plates are possible if letters and digits cannot be repeated. Well, this changes the problem a little bit. You're still filling in the 6 blanks on your license plate. One too many. But because you can't repeat items, some of the numbers will change. You will still have 26 choices for the first one. You will still have 10 digits for the first digit blank. Now the next blank, you will only have 9 choices because you already used one and you can't repeat it. For the next blank, you would only have 25 choices because you used a letter at the beginning, then 24, then 23. And when you multiply all of those values together, you will get 32,292,000, which is still a large amount, but if you look, just by not being able to replace or not being able to repeat, it decreases the amount by about 13 million. So it does make a big difference. Now what we've been working on are different arrangements. Another word for arrangement is permutation. Okay? When you are rearranging all of the items, it's similar to the problems we were just doing. For example, if I wanted to know how many different ways I could rearrange the letters A, B, and C, I can set it up similar to the last example. I would have 3 choices of letter for the first blank. Then I would only have 2 letters left for the second blank and only 1 letter left for the last blank, which would give me 6 different ways I could rearrange those letters. Now this is a pretty easy problem, but what if I had asked you to rearrange all the letters of the alphabet? That would be a really big pain to write out 26 times 25 times 24 and so on, all the way down to 1. Well, we do have a math function that will allow us to do this more quickly, and it's called factorial. This problem can actually be typed in the calculator using this symbol, and that symbol represents factorial. And when you type in this function, the calculator knows that you're wanting it to multiply these decreasing integers, and you will get the same value. All right, so for example, if we wanted to type in, and I'm just making this up, 6 factorial. If you're using a scientific calculator, you would type in 6, and then on your calculator right here, you have this PRB, that stands for probability. All of your functions you're going to need will be under there. You would hit that button, and then scroll over and choose the factorial symbol, and when you hit enter, you will get the answer, and it's 720. If you're on the graphing calculator, just so you know where these are located, you would again, let's see if you can see that a little bit better. Well, this one's dead. What you would do is you would type in 6, you would hit the math button, and when you go to this menu across the top would be a probability menu. You would go there and choose your factorial symbol as well. This can be used when you are rearranging all of your items. And so if we look at the next example, it says a television news director has 8 news stories to present. How many different ways can they be presented? Well, you have 8 items, and you want to know the number of ways that you can rearrange them. Well, 8 factorial gives you a value of 40,320. So if you take 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, you will get this answer. This is much faster. Now, another thing you need to think about is, what if you're not arranging all of your items? Let's say that I had 8 people running a race, and I only wanted to know the different ways that they could be placed in first, second, and third place. I'm not interested in the placing of all the people, just the top 3. This is when we have to look at a formula that's the permutation of n objects taken r at a time. Okay? Now, the symbol that you will use here when you're not rearranging all of your items is NPR, and this stands for n items arranged r at a time. So if you come down here, 5P3 represents that I have 5 items, and I am arranging them 3 at a time. Well, you would need to type in 5, then go to your probability menu, look for NPR, select that, and then you will hit 3. And when you hit enter, you should get an answer of 60. So just to show you that again, let's see if I can get this so you can see it. There we go. You type 5, you go up to the probability menu, NPR is the first one, just select that, type 3, and then hit enter, and you will get an answer of 60. So there are 60 different ways you can take 5 items and arrange them 3 at a time. 4P1, 4 items arranged 1 at a time, you should get an answer of 4. 8P5, 8 items arranged 5 at a time, you should get an answer of 6,720. If you look down here at these examples, again going back to the 8 news stories, it says if only 3 of the stories will be presented, how many possible ways can a lead story, a second story, and a closing story be presented? Well, you have 8 stories total, arranged 3 at a time. And you should end up with 336 ways that can occur.